In the previous video, we answered the question, how does the router know which routing entry to use if a packet that comes in and the destination IP address that it sees matches more than just a single route in the routing table? And the answer is it chooses the longest match. Longest meaning if there's a 32-bit route that matches, it's going to use that. And that's going to be preferred over a route that's maybe 20 or 16 or 8 bits long. So it's going to choose the longest match from the routing table. So that's the concept. And in this lab, I'd like to walk you through a scenario where we can see that happening before our eyes. So here's our plan of attack. We'll do our work on router 1, and we'll add these routes or make sure these routes show up. And then we'll create a loopback over on router 4. I'll walk you through it step by step. We'll create a loopback on router 4 with this IP address. So we actually have a target we can ping against. And then we can witness over here on router 1 which of these routes, because they all match, which of these routes would be used based on the router choosing the longest route in the routing table. So if you're logged on to a computer to our CBT Nuggets website, take a moment now, launch the live lab, and join me as we do this together. All right, my friend, we are here at our administration machine, which is DCNUG. We can bring up the topology if we want to take a quick peek at that as well. And then let's open up PuTTY. And we'll open up sessions to R1 and R4. Let's start on R4. So here on router 4, let's create a new loopback. So we're going to go into configuration mode, interface. Let's create loopback 777. I live in Las Vegas, so that means luck, 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 and we'll press enter. And let's give it the IP address of 192.168.1.1 with a 24-bit mask, just like that. Now, behind the scenes, I have a routing protocol installed on R4 named RIP along with OSPF, but RIP is responsible for the 192 network space, and it's going to be advertising it via RIP to the other routers. So that's happening automatically just by adding this new loopback interface. So if we make a road trip over to R1, and on R1 we do a show IP route, and then press enter, and then hit spacebar a couple of times, that'll bring us to the end. We can see that this route, 192.168.1 with a 24-bit mask, has been learned via RIP, and there's two paths. There is one going through .3, which is R3's address, and one going through .2, which is R2's address, and they are both in the routing table as a review because they both have the same administrative distance of 120, and they both have the same cost of 2, which from RIP's perspective is a hop count, meaning how many routers we have to go through to get to that destination. So what I would love to do here on R1 is I'd like to create some additional routes, including static routes, so that we can actually play with the lengths of the networks and also see which route is going to be used. So follow along with me as we create our first route, which is going to be a 16-bit route. So we'll go into configuration mode and we'll do IP route, and let's do the 192.16.0.0 space and a 16-bit mask. Now, I know that this is a Class C address. So when we use a shorter mask than the default, we're actually doing a summary or a supernet, and that's perfectly fine. The router has no problem with that. And let's use as a next hop 10.13. Let's go to R2. Let's do 10.12.0.2. Because if we look at the topology, going up here through 10.12.0.2, which is R2's next hop address, that's a much faster path to getting that loopback on R4 than going across the fast Ethernet segment down here on this path. So I'm going to use 10.12.0.2 as my next hop. And we'll press enter. So now if we do a do show IP route and press enter, and then just hit spacebar a couple times to go to the end of the output, you'll notice that we've got our static route, the 16-bit route for 192.16. I just realized I typoed that. All right, well, I'm going to fix that right now live. So I'm going to hit the up arrow a few times. I'm going to bring up that command that I input incorrectly, do a Control A to go back to the beginning of that line, type in no space and enter, and that route is now gone. I'll hit up arrow a few times, and I'll actually put in the right address. All right, it's a little bit of visual troubleshooting right there. Then let's do a do show IP route, hit the space bar a few times, and we'll check our work. Yeah, that looks much better. So here we have the static route that I just added for the 16-bit network of 192.168. And then we have a longer route of 192.168.1 with a 24-bit mask learned via RIP. So the point I want to bring up here is that if a packet came into this router and the IP address was destined to 192.168.1.1, you see how it would match the first 16 bits of this, and it would match the first 24 bits of that. And so from a router perspective, the router has to decide, okay, which route do I want to use? And the answer is going to be the longest match from the routing table. So because the 24 bits is longer than the 16 bits, it would choose the 24-bit route. And we can verify that. It's so cool. We can verify that by doing a do, because we're in configuration mode, and a show IP route. And let's put in that destination of 192.168.1.1 and check this out. It's showing us the preferred route that it pulled from that it's going to use to forward packets. And it's the route that was learned via RIP. It has the administrative distance of 120 and has the length in the mask of 24. And if that RIP learned route went away, then it would fall back to the next best option, which is the next longest match, which would be the static route that we just configured. So let's add a couple more. Let's add another route for 192.168.0, but instead of a 16-bit mask, let's use a 22-bit mask. So the command would be IP route 192.168.0.0. That's what the network looks like. And for a 22-bit mask, it'd be 255.255. So that's 16. And then for the balance to get to 22, we could use the old table if we haven't memorized it, which is 1, 2, 4, 8, 16, 32, 64, 128. And so we're at 16, we're going for 22, so it'd be 17, 18, 19, 20, 21, 22. There's the dividing line. We just add up all these bits that are on, and that would equal 252. So our mask would be 255.255.252.0, and that would be a /22. And because I don't quite yet have the writing to iOS commands conversion tool implemented yet, I need to actually type those in. So let's do that now. So we'll put in 252.0, and then we'll use that next hop of, and it's going to copy paste that right here, 10.12.0.2. So I'm going to click and drag across that IP address, right click, paste it in, and press enter. Fantastic. So that's a 22-bit route. So now if we do a show IP route, and then hit spacebar a few times to go to the end of the output. Now we have our 22-bit static route for the 192.168.0 network. But again, if we were going to ping an IP address at 192.168.1.1, it would once again choose this route because this is a longer match. Now, I've got a question for you. What would happen if we added a static route, a 24-bit static route for the 192.168.1 network? What would happen to this existing route in the routing table, and why? And if you're saying, well, Keith, I've watched several of these videos and I've been doing some labs, and here's what I think would happen. If we had a static route, a 24-bit route, and we put an administrative distance that's lower than 120, because that's the current route that's there, the new route would take over because the Cisco router for an exact same network is always going to choose the lower administrative distance. And if that's what you're thinking, awesome, because that's the truth. Let's do it. So let's do it. Let's add a 24-bit static route for 192.168.1 and watch the routes change. So we'll do an IP route for 192.168.1.0 with a 24-bit mask. And we'll specify the next hop is our good buddy R2. I'll click across that, copy it, and right-click to paste it in. And we'll use the default administrative distance, which is going to be 1, and that's going to win. So we'll put that in. A couple up arrow keys in. And then we'll hit space to go to the bottom of the output. Notice that the RIP route is gone for that 24-bit network. And that's because administrative distance of 1 is King Kong over an administrative distance of 120. So the RIP learn route is no longer in the routing table. It's not going to be used. And let's do one more. Let's do a 30-bit route as well. And to do that, we'll hit the up arrow key a couple of times. And we'll specify instead of a 24-bit mask, let's go ahead and do a 30-bit mask, which looks like that with the same next hop. And then if we exit out of configuration mode and do a show IP route, and then hit space a few times. So check this out. Now, if this router had a packet coming in destined to 192.168.1.1, it would match here, meaning the first 16 bits would match this. The first 22 bits of this one would match. The first 24 bits of this would match. And the first 30 bits of this would match. So, and also not even shown here on the screen is if there's a default route, that could also match as well because the default matches everything. So the route that the Cisco router is going to choose to use based on matching is going to be the one with the longest match, the longest network match, which in this case is this. And how do we verify that? Well, we can verify it by doing a show IP route, space, and then plug in the destination IP address, and it will tell us which route it's using. So let's do that. Let's do a show IP route. And then we'll put in the destination IP address of 192.168.1.1 and press enter. And it's showing us exactly the route that it's using, which is this bad boy right here, the 192.168.1 with a 30-bit mask. It was learned via static. It has an administrative distance of 1, and that's the route that's going to be used. And if we tried to ping that IP address, which is hopefully going to work, let's try it. Ping 192.168.1.1, which is that loopback over on R4. Yeah, it works. And we could also do a trace. Trace out to 192.168.1.1 and press enter. And that's showing us the path it's taking. So it's using R2 as the next hop and then directly down to R4. And that's because our static route said to use 10.12.0.2 as the next hop for the route that's being used for that forwarding decision. So in this lab, I snuck in a couple of reinforcement things that I thought were important to see. Number one, we slipped in the fact that if we add a route that has a better administrative distance, it's going to supersede or replace an existing route that has a lower AD. We also identified how we could prove which route is being used by doing a show IP route, plugging in the destination IP address, and it will show you which route from the routing table it had selected for the forwarding decision. And then lastly, and most important for this video, I wanted to reinforce the idea that if there are multiple matches in that routing table, the Cisco router comparing the destination IP address against the routing table is going to choose the routing entry with the longest network match, and that's going to be the one that it uses. So thanks for joining me in this lab and video. I had a great time putting it together for you. I hope you enjoyed it as well, and I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.